Okay, we are starting to talk about loops today. And so everybody has a handout. And the handout looks like this. So we're cutting out the triangle and the four squares, and we're going to put them on the grid in different patterns. Okay, later I'm going to come around and see how OCD you guys are, see how perfect your circles are. I think there may be a higher percentage of OCD people that take this class. Okay. Riley, you are the smartest one here. She cut out her circles as squares. I'm like, yeah, that saves a lot of time. Okay, so keep cutting, but I'll start so we can finish. We are running about one class behind, so we're going to try and do double on block day, and we'll see how that goes. Okay. So we're talking about loops today, and we're going to play with our little triangle robot, and the circles are barriers. So you'll see how those work in a second. But if you can imagine, a loop is just going to be something that we repeat over and over and over again in a loop. And you might have heard the term an infinite loop. Hopefully we never get stuck in an infinite loop. Okay, so place your triangle in the middle, the bottom middle square pointing up. And we just have one command today, move forward. So when you see that command, it's going to move the robot one square up. Okay, and if we then use this command 4 times, it's going to move your little triangle guy all the way to the top. So go ahead and run this 4 times and move your guy to the top. Okay, so this is too repetitive. We never want to be repetitive. So we're going to use something called the while loop. Okay, so we're going to illustrate it with a flow chart. And here's how it works. So while something is true, the code in the loop is going to run over and over until the something is no longer true. Okay, so sorry, can't see that. Let me minimize that Zoom thingy. Okay, so first we create a variable called steps. Steps is 0. Steps is just going to be our counter, right? So steps is 0. So while steps is less than 4, let's move forward and then steps plus plus. Plus plus is shorthand for +1. Okay, so we're going to move forward 1, and then we're going to add 1 to the steps. So steps will be go from 0 to 1 to 2 to 3 to 4. Okay, so this command does the exact same thing as for move forwards, right? So if you run that, okay, so if you run this, great. Is 0 less than 4? Yes. So we're going to move forward. We're going to add 1 to steps. Okay. Your guy moves forward. Okay. Now this steps is not 1 anymore. I'm sorry, it's not 0 anymore. It's 1. Second round. Okay. Is 1 less than 4? Yes. True. So we're going to move forward 1, and then we're going to add 1 to steps. Next round. Is 2 less than 4? True. Move forward, add 1 to steps. Okay. Now is 3 less than 4? Move forward, we add 1 to steps. Is 4 less than 4? Kind of a trick question, kind of not. It's false. So we're going to exit the loop. We're going to exit the loop. And then we would, if there was more code, we would continue running the code. Okay. So if you did that on your board, you would move forward 4 times, and then you would stop. Sorry, you wouldn't stop. Do you know why I didn't stop? Okay, let me go back. So run this program. Steps is 0, while steps is less than 4, move forward. Okay, so that's true. 0 is less than 4, we move forward. What happens next? We go through the loop again. Is 0 less than 4? Yes, we move forward. Next round. Is 0 less than 4? Yes. So we just keep moving forward. It doesn't ever stop. Okay. So this is an example of an infinite loop. Because we used to add 1 to the steps so that eventually this would be true and we could exit out of the loop. Okay. In this instance, that is never false. So it just keeps going. It's an infinite loop. Okay, let's add a command. Turn right. Okay, this command turns the robot 90 degrees to the right. So start your triangle in the second square from the left on the bottom, pointing up. Okay, and go ahead and run this program. So go ahead and move your triangle guy. Round 1, what happens? Round 2, what happens? Round 3, and round 4. Okay, here's round 1. You probably saw that. Round 2, round 3, round 4, and then we exit the loop. kind of basically just went in a circle, right? And some people would say, why did you do that? You did nothing. Well, we went in a circle. Okay. So your while loop has 3 parts. Okay. You have a counting variable set to an initial value, usually 0, because we always start counting at 0. You have a Boolean expression here that checks the condition of that variable. And then you have a statement which increases the variable or decreases, increases or decreases the variable being checked. And if this piece is missing, it's an infinite loop because it'll never be, the condition will never be false. Okay, so you guys are used to Booleans, you're used to checking things in your if and else statements, right? So now we just have another piece where we can repeat code over and over again while we check to see if that is false. Okay. You need to know the while loop. Create your variable, while your Boolean, do the code. You need to know that, but you're never going to write a while loop. In my opinion, you're never going to write a while loop. You might, but for the most part, you're going to write a for loop. Okay, and then a for loop is just going to combine all 3 of those statements, all 3 of the parts into one statement. So a variable that starts at initial value, we're going to say var I equals 0. Okay, then you're going to have your Boolean that's checking something, I less than 4. And then you're going to have your counter, which is I plus plus. Okay, so a for loop is just a really compact way to write a while loop. Does that make sense? Does that make sense? Okay, create your variable, check your Boolean, and increase by 1 every iteration. Okay, a loop is example of iteration. Okay, iteration is that computer science word or term that you're going to need for the AP test. Iteration is a repeated portion of an algorithm, a program algorithm, which repeats a specific or specified number of times until the condition is met. Okay, so if you have a question, just stop me. But you're going to often write your for loop, and you're going to adjust different parts of it, right? Usually, this part is not going to change. I plus plus is not going to change. The only thing you're probably going to change is the number here, right? Because if you have a command that you want to run 10 times, then you're going to say I is less than 10. If you have a command you want to run 8 times, I is less than 8. Okay. And if you have a command that you want to run for the length of a list, I is less than list name dot length. Okay, does that make sense? So that's mainly the part that you're going to change. The rest of it is not going to change. And then, of course, the code that you're going to run every round is going to change. Okay, so let's add another command. Turn left. Okay, obviously you know what that does. So start your robot in the bottom left corner, facing up, facing the top, and we're going to run this. Okay, so if you want, you can keep track of your I on a scrap piece of paper. If you want a scrap piece of paper, I can give you one. You might have one. Okay, so round 1, what's the value of I? 0. Okay. Gonna move forward, turn right, gonna move forward, I'm gonna turn left. Okay, round 2, gonna do that again. Round 3, I'm gonna do that again. Then I think I'm gonna stop. Round 1, round 2, round 3, for round 4, I is 3, so it's gonna exit the loop. Okay, go back. So we exit the loop there, okay? This is I don't know if this is a little less confusing, but in general, if you're starting at 0, whatever number you have there is how many times you're gonna run the program, and then you're gonna stop. Okay, does that make sense? So you're gonna run 3 rounds and then stop. It's a little confusing because we did start counting at 0. So you might expect us to run the program 4 times because we started at 0. So there's that. Okay, so move your robot. Start on, not in the bottom left corner, but 1 up from that, and we'll run a new program. Okay, so go ahead and run this program and see where does your robot end up. Okay, so round 1, I is 0. I'm gonna move forward. I'm gonna move forward. Turn right. I'm gonna move forward. Okay, round 2. I'm gonna move forward. I'm gonna move forward. I'm gonna turn right. I'm gonna move forward. So I expect that to go down. Round 3, I'm gonna exit the loop, so I'm not gonna do anything. Okay? You following? Okay. It does help to move the robot thing. Okay. All right, so I missed something. Did this always say less than or equal to? Did this always say less than or equal to? I don't remember. I think it always did. So in this case, if we're checking if it's less than or equal to, that's still true. So we're going to run the program one more time. Okay. I almost never change this because it's going to mess you up. Okay. But you might have to. You might have to in your instance. Okay. So this round 3, you are going to have a round 3. Move forward to turn forward. Okay. And then 3 is no longer less than or equal to 2. Okay. So what's the lesson? Do watch this. Normally it's just equals. I'm sorry. Normally it's just less than. But you might have an instance where you want to write it less than or equal to. Okay. Not terribly common, but you might want to do that. Just depends on what you're checking. Okay. Let's try it again. Okay, start in the middle of the grid. And let's run a program. Okay, so let's see. the thing we're checking is back to normal. So it looks like we're going to run 2 rounds of this. Okay, so looks like we're going to run 2 rounds. So let's run those 2 rounds. Move forward, turn left, move forward, move forward. Move forward, turn left, move forward, move forward. Okay. Okay, round 1 here. Went down 1, and I'm pointing downwards. Round 2. Came back to where you were, and I believe we now exit the loop. Okay. Good. Okay, let's add, we're going to start in the top left corner facing the right, and we're going to add 2 barriers, just like you see in the picture. And we're going to add some new commands. So can move left. So if you can move left, then you're going to do something. If you can't move left, then you can't. Okay. Imagine there's a wall around your grid. So starting here, can I move backwards? No, I can't. Can I move left? No, I can't. Okay, so from here, I can move forwards or I can go right, but I cannot go left and I cannot go backwards. Okay. How nice. That's it. That was it for that. Okay, so if I'm here, if I reset this, okay, can I move forward? True. Can I move right? True. Can I move left? False. Can I move back? True. Okay. Same thing. You don't have to put it on your paper. Can I move forward? True. Can I move right? Back. Left? No. Back? No. Okay. Let's actually run a program. Okay. So we have a loop. Looks like we're going to try to run the loop 3 times. If you can move right, turn right and move forward. Okay. So how is the loop going to work? After you do the if, then you turn left. If you can move forward, move forward. And it looks like all of this is in the loop. So all of that is going to be in our round. Okay. So round 1, I is equal to 0. Okay, you end up there. Round 2. Okay, there's a round 3. Round 3 might be a little different. Okay. Okay. Is that where you ended up? Okay, so what happened? When we're moving the robot thing around, you move different places if spaces are open, right? So the first round, we just moved here. And then, we're pointing up and we kind of stopped because we couldn't move to here. In the next round, we did all the actions, which was turn, move, up, and then, okay. And then in the third round, we couldn't move right. So we didn't do any of that. But what we did do was we turned left, and then we couldn't move forward. So we didn't do that. And that's just where we ended up. Okay. Okay, are you guys getting how the if conditionals are interacting with? Okay, so try this one. You got all 4 barriers. We're starting bottom row, second space from the right. Okay, here's the program. So what are you seeing? So I'm seeing we're going to run this program. It looks like 4 times. We're going to go 4 rounds. Everything is in the loop. So we're going to check everything for 4 rounds. So in the first round, if I can move forward, turn left. If you can move forward, turn right. So in the first round, I'm expecting to come here and then be facing up. Okay. Second round, if you can move forward, turn left. If you can move forward, move, but we can't. So turn back right. In the second round, I'm expecting to just be here. Okay, next round, round 3, if you can move forward, turn left. If you can move forward, turn right. I'm expecting to be here, pointing up. Okay, next one. If you can move forward, which we can't, so just turn left. If you can move forward, turn back right. I'm expecting to be here, pointing up. Okay, after round 4, I expect to exit the loop. And so that's where I'm going to stop. Okay. This is, okay. You kind of get it? I'm going to skip this unless you really want to have fun with creating a loop that can navigate your board. Okay, so your 2 pieces of code that you need to know for this lesson is the while loop and the for loop. The while loop uses a Boolean condition to repeatedly run a block of code. If it's true, you run the code, right? Then you check the condition, run the code if it's true. And once it's false, it stops. You exit the loop. Okay, the for loop is what you're going to see all the time because it just, instead of writing that whole thing, it just condenses it all down into one line of code. and then the code you're actually running is in there. Okay. All right, take a look at this. Maybe you'll explain this in another way.
My name is Jerome Holman, and I work in the Windows Devices group at Microsoft. It's basically a team where we build cool stuff, tablets, phones, things like HoloLens that hopefully will excite and delight customers. Computers are not infinitely fast, but they are much faster than human beings at many tasks. In 2014, the fastest computer in the world was clocked in at an astounding 33 quadrillion calculations per second. Now, for some tasks like composing a song, we generally think human beings still do a better job. For highly repetitive tasks that can be automated, computers are much, much better. Programming languages usually have a few different ways to define and control behavior that should repeat. These are usually called loops. They go by different names in different languages like for loop, while loop, do while loop, for each loop, repeat loop, and so on and so forth. These types of loops have small differences, but all of them are just different ways to get the computer to execute some lines of code repeatedly. The generic term for looping is iteration. Iteration is just a fancy word that means repeat. It usually is in reference to the repetition of a process or a procedure. This is why iteration is a good generic term. Often in programming, we have an algorithm that just needs to repeat a specific number of times, or repeated while some condition holds true. We're going to show you how to use a looping structure called a for loop in JavaScript. You can find for loops in the control section of the toolbox. It looks like this when you drag it out. A for loop in JavaScript, like this one, is just a type of counter loop. It counts up from 0 to the number you type in. Why does this simple for loop look so complicated? JavaScript, unlike some languages, doesn't provide a simple repeat loop structure. The for loop is a very powerful and versatile looping structure for both advanced and simple tasks. We're just keeping it simple for now. Let's do a little experimentation. You can drag any commands you like inside the for loop block. These commands will be executed over and over for however many times you specify in the loop. When you run the loop, notice the App Lab highlights each line as it executes. Now, why does the for loop block highlight after each iteration of the loop? That's because the for loop needs to check its counter every time to see if it should stop or run the commands inside the loop one more time. Well, that's not terribly exciting, but it's because we're not really using the computing power that looping gives us. Instead of looping this piece of code 4 times, let's loop it, 200 times and see what happens. Now that's more interesting. One thing to note about loops is that your code will still execute from top to bottom as before. You can put lines of code before the loop if you need to get something set up before the loop starts. Likewise, after the loop is done executing, it will pick up on the line right after the loop. For example, if you want to move the turtle before drawing this figure, I could use a move to command before the loop. And if I want to draw a red dot to see where the turtle ends up, I could add lines after the loop. You will use the same top-down design in many of your projects. These problem-solving techniques will help you identify where loops belong in your code. You still might want to write a function to do a small part of your program, and then write a loop to call that function. Take, for example, the problem of trying to draw this. You might recognize that this is just a bunch of squares, each one rotated slightly before being drawn. Previously, we would have had to make a function to draw a square. To get the 10 rotating squares, we would have had to call this function 10 times, turning a little each time after we called the function. This would have involved a lot of copying and pasting. This code works, it does, but it's very repetitive. Let's just see if we can simplify our code with a loop. We already have a working function that does a piece of the problem once. We can easily stick the function call into a loop to do it multiple times. Clarity and readability are important considerations when programming. As we can see, this code is now much more readable. It's obvious just from looking at the loop that the intent is to draw a square a bunch of times. Loops are a powerful programming construct that uses the computer's primary advantage over humans, that being their amazing speed. By repeating commands as many times as we wish, loops allow us to solve new problems at a scale that would be impossible without computers. There is still much to learn about the loop, but the concept is simple. Loops repeat commands as many times as we need. Now you know how to use a simple loop. You can use them in your programs and take advantage of your computer's power and speed.
Okay, so iteration. Make sure you know that term, especially so when you start your AP project, which will be a couple months after Christmas break. Your programs need to have three things: selection, iteration, and what was the third thing? Can't think of it. All right, well, you'll see it over and over again: selection, iteration, and something. Okay, so iteration or looping is just that repetitive portion of an algorithm. Okay, and an infinite loop occurs if the ending condition will never evaluate to true. Okay, usually doesn't happen with a for loop, but it would happen with a while loop. Of course, I guess you could do it with a for loop. Okay, and I think that's it. Alrighty.